In the previous video, we learned about a container. Now, let's continue along that path and examine more details about Docker itself and its architecture in this video. If you wish to read more about the Docker concepts, the document behind me contains more details, a link to which is provided in the description of this video. Docker is centered around the Docker engine, which is the server which is running as a daemon within your system and then exports a REST API which you access from the Docker client in order to issue commands to it. Let's take a quick look at the structure of your Docker application. So here we have the server or the Docker daemon, which forms the nucleus of this whole arrangement, and the server daemon exports a REST API. If you have taken my courses on Coursera, I've explained to you REST API in those courses. Now, so if not, I'm sure you're familiar with what REST API is. Now, this REST API is accessed by the Docker client in order to issue commands to the Docker daemon. The Docker daemon itself works around these four concepts. Container, we have already examined in the previous video. We'll look at it one more time in a later part of this video. Then we'll also ask ourselves what an image is and what is its relationship to a container later on. We'll examine network and data volumes in separate videos. Now, to examine this further, let's ask ourselves, what is the typical way that the Docker application runs on your system? So this is the typical architecture of your Docker system. So as we mentioned, it uses a client-server architecture with the daemon acting as the server. So typically, the Docker system is organized like this. So the Docker daemon is the one that orchestrates the entire system. And using the Docker client, we issue commands to the Docker daemon, like the Docker build, Docker pull, Docker run. We have already seen Docker run. We'll look at Docker build in the next video. So all these commands are issued by the CLI that we have been using from the prompt to issue the commands. You can also use a GUI-based interaction with the Docker daemon using the Docker desktop or Kitematic if you're using Docker Toolbox. Now, the Docker daemon works with images in order to create containers. And also, the Docker daemon itself, the images themselves may be shared in a registry for other users to make use of. One most popular registry is Docker Hub. You can run your own private registry if you so choose to within your organization. But if like me, you are a general user that is using or learning about Docker, then we use Docker Hub, which is a public registry. So you can load images to the Docker registry and share it with others. And when you want to create a Docker container, you may pull down an image from a Docker registry and then use that image in order to construct a container. Now, let's ask ourselves, what is an image and how is it related to a container? As stated in this documentation, an image is a read-only template with instructions for creating a Docker container. What does that mean? Typically, when you create an image, you specify how to package the environment or the set of software which is required for your application to run. Say, for example, you are creating a container to run a web server. Then the container should contain all the software required to run the web server, plus your own website that you want to serve up through the web server. So all this needs to be packaged together inside an image. Now we will see in the next video how we use the docker build command to build an image for running a web server. So the image itself, the Docker registry shares a lot of images for users to make use of. You can build your own image based upon an existing image from Docker Hub. So you can build it in terms of layers. We'll look at how that is done in more detail as we proceed along in this series of videos. Now, how is a image related to a container? Now, as we said, the image is a template for creating a container. So which means that the container itself is a runnable instance of an image. An image exists in a registry or on your computer. From an image, you create a running container. Furthermore, the container itself provides a sandboxed environment within which your application is running. So it is completely isolated from other containers that may be running on the same computer at the same time as your container. So this brings the advantage of using a container. Containers, as I said, are a lot more lightweight compared to virtual machines. Virtual machines are heavyweight because they also need to include the guest operating system. A container doesn't have a guest operating system included inside it, but instead it leverages the host's operating system to run the container. Docker itself is not completely new. The underlying technology behind Docker has been in existence almost all the way back from when Unix was first created. Docker leverages those technologies in a new way in order to provide you with the sandboxed environment to run your application. One of the technologies that Docker leverages is the namespaces, which is supported in Unix. This namespace provides you the isolated workspace for your container. The second technology that Docker leverages is control groups. Control groups limits the application to a specific set of resources. So that way it controls what the application can access and how much of the resources on a computer the application can access. So that's the second part that is required for your container to run. And the third part is a union file system, which allows you to create a file system in terms of layers, and which is very lightweight and fast. We will see how we actually make use of file systems and then map files into a container in the later videos. With this quick understanding of Docker, let's proceed on to examine how we can go about creating our own custom image for our application.